Hello everyone, we come from Rajasthan Multi School. Today we're going to present about our projects, the application of ultrasonic wave for algae removal. This is our overview. Okay, continue to the introduction. Eutrophication, or known as algae bloom, is a phenomenon that occurs from the water source that rich in nutrients like nitrogen and phosphorus, causing the algae to grow rapidly and fat on the surface of the water. When the algae die, the decomposition process by bacteria that use oxygen dissolved in the water will occur. This cause thus the water become polluted and smelly. Algae is also effective to aquatic life too because they can produce toxins that act on the nervous system, livers, and other organs. In the past, we used many methods to solve this problem, but most methods affect to environment, use a lot of electricity, and may be expensive. The new way we present is ultrasonic wave technology, work by vibration to the vacuole of algae cells that make them down to the water, resulting in red sunlight and causing them to die. This is our objective, to design and develop a prototype of ultrasonic wave generator for controlling and eliminating algae and restoring water quality in the water source that affected by algae bloom within a radius of 100 meters, can be report status and can be controlled within the internet. And to enhance knowledge and develop community quality of life regarding the knowledge and water resource management.
The next part is methodology. We will talk about the LGD prosthetic system using ultrasonic wave. Consists of 1. Ultrasonic generator, 2. transducer, 3. water bath, 4. display of overall system. The next slide is ultrasonic wave imaging device that use piezoelectric transducer. Both of participants of convene between electrical and mechanical energy will give a resonance frequency. The next is structure of ultrasonic wave generator circuit that consists of half-brigade condenser circuit, gate drive transformer, frequency generator circuit, high frequency transformer, resonance circuit, solenoid gearhead. The next is structure of operation of ultrasonic algae removal and control system high frequency consists of 3 parts. The first part is sensor and display part. The second is control part. And the last is energy collecting and generating part. From the slide, we talk about mixed together. This is the structure of our application. In the theory section, we're using 2 main physical theory in our project. The first one is speed of solid liquid. Because liquid have volume deformation, making it cannot sustain the shear force, then the speed of solid liquid can be determined by following equation below. The last one is piezoelectricity phenomenon. It consists of 2 types. The first type is direct phenomenon. It appears when you put the physical force into the substance that called piezoelectric material, making their dipole bond shapes and making their central ions stick together, generating the voltage. And the type 2 is reverse phenomenon. It's the phenomenon that's using the opposite process but based on the same method. The method is called pouring effect, arrangement process, and change shape molecules that have dipole bonds in the same direction and in orderly manner. The next is results and discussion section. This is the testing of intensity of ultrasonic from wave generator at different distance. As you can see, we do it twice, and the result is the intensity of wave is inversely proportional to different distance for wave generator. And this is the testing effect on algae. As you can see, those figures show characteristic of algae used and without using the ultrasonic wave in the water tank in the 30 days. And the result is the ultrasonic wave aim to eliminate and can prevent their growth but threat to leave the remains of algae behind.
Next, testing the effect on aquatic animals. We use tilapia fish in these experiments. These tables shows the effect on the egg hatching rate and the survival rate of juvenile fish. According to this table, the ultrasonic wave had no detectable impact. And this table shows the effect on growth performance and survival rate of juvenile fish after passing through the ultrasonic during the egg stage for 28 days. As the tables, it can be concluded that the ultrasonic wave had no effect. Next, comparing the effect of two different ultrasonic frequencies, 20 and 40 kHz. This table shows that the both ultrasonic frequency had no significant different effect. The mortality in tilapia fish is due to natural selection rather than the experimental treatment. It can be concluded that the fish were not affected. Next, testing the effect on the other aquatic life. These two tables shows the impact of both ultrasonic frequencies on the mortality rate of other aquatic species with exposure lasting only 30 seconds. These tables for 20 kHz ones and these tables for 40 kHz ones. It is clear that both ultrasonic frequencies had an effect on zooplankton but did not affect the fish. Lastly, testing the electrical conductivity or EC value. From the table, it can be observed that the EC for tank with ultrasonic device is tended to decrease over a period of 28 days, and improving of water quality. It was also found that the water quality was better and more effective for the algae control for the 40 kHz ones. Now, let's summarize. A prototype was developed and tested to eliminate fast-growing algae in reservoir tanks for 30 days. It was able to completely stop the algae growth from day one onwards. 2. The ultrasonic wave had no effect on the fish, but affect the zooplankton, and this is the problem that we will continue to find a solution for. Suggestion: this study was carried out solely on a laboratory scale as such no testing was conducted in natural water environments. We would like to thank for the support. These are our references. Thank you for your attention. สวัสดีครับ